483. And synthetic division is in this section because it's a type of polynomial division. So we won't be messing with long division. It's just going to be what we call synthetic division. I'm not sure if y'all did synthetic division in foundations class or not. So, synthetic division. I can use, synthetic division for three things. First thing I can use it for is to find the quotient and remainder. Now, finding the quotient and remainder, that's what the support will be using, okay? Same thing I can use synthetic division for is to find function values. So we will do that in college algebra. And then last thing we can use it for is to determine if a number is a zero. And remember, zeros are basically like solutions on these. So we're going to focus with the function values in here and with the zeros. And like I said, support will deal with the quotient and remainders. So the best way to explain synthetic division is to actually sort of work a problem out using it. So what we're going to do here is we're going to use synthetic division to find function values. So we got a little theorem called the remainder theorem, and the remainder theorem tells us I don't know if that's how to spell theorem, but close enough. So the remainder theorem tells us that when using synthetic division, the remainder is equal to the function value. So what that means is if you were trying to find f of 5, then f of 5 would equal the remainder that we get from doing the synthetic division. Okay, so I'm going to turn this page over so I got a new page to start on. So we're going to use synthetic division. We're given f of x equals x to the third minus 13x squared plus 52x minus 60. They want me to find f of 2, f of a negative 5, and f of 6. So basically, I got three things they want me to find. So I'm going to find each of these individually, okay? So first, I'm going to work on f of 2. So what you want to do when you start synthetic division, you need to write out all the coefficients of the polynomial. So first thing I'm going to do is write the coefficients. Now, notice I got an x3 term, x squared term, x term, and then my number. If I was missing any of my terms, I would have to use zeros in place of that, okay? So I don't have that on this example because I got my x3, my x2, my x, and my number. So write out the coefficients. So that would be a 1, negative 13, 52, and then a negative 60. So the first thing I did was write the coefficients of the polynomial. Now, make a little space, and then up under your numbers, draw, it's like half a box, and then I boxed in the last section. Where I boxed this in on the last section, that's going to be where my remainder is found. What I get on the first part of my box is going to be the quotient. Or remember, the quotient is what you get after you divide your polynomial by our first number, which was a 2. Now, over here to the side, I would put a little box for what I call my C. And the C is basically what I'm going to be dividing by. So in this case, it'll be the 2. Since that's the first function value they want me to find, 2 will be in my little box. All right, so like I said, once I divide, this will be my quotient, and then over here will be my remainder. All right, so I'm going to draw this again so that it looks better when I'm working it. All right, y'all, so synthetic division is a repetition in a pattern. So the first thing I'm going to do is bring the first number straight down. So bring first number down. So that would be a 1 down there in my first box. Now, we need to find the number that's going to go here under the negative 13. So to get that number, whoops, y'all, let's put a 2 in there instead of my C. I think I was saying that's where my C will go, and I wrote C instead of my 2, okay? So 2 is the first C I'm using. So we need to get the next number that's going to be under the negative 13. To get that number, we take the number we brought down, multiply by the 2, and put that under the negative 13. So multiply 1 times 2 and then put under the negative 13. Now that I got 2 numbers in this column, I'm going to add this column together. So add the column. So negative 13 and 2 gives me a negative 11. So add the column and bring that number down. And y'all, now we're going to repeat the process. The negative 11 multiplies by the 2, and that gives me what? A negative 22. Okay, so what we're doing here, we're just repeating the process. So now, 52 and negative 22, when you add them, give you a 30. So next what you would do, 30 times 2 gives me 60. And look at that, negative 60 added to 60 would give me a 0 remainder. So what that means is f of 2 equals 0. Okay, so if you put a 2 in for every one of these x's, your final answer would be 0 on that, okay? So now that we know what f of 2 is, we got to find f of negative 5. So if you are good on that, I'm going to pull this paper over. I'm going to write my coefficients, which was 1, negative 13, 52, and negative 60. So let me draw my little box. And the second number I had to find was f of a negative 5. Now, I will say this. When you're doing the quotient and remainder stuff in support, you'll change the parentheses, the sign of the numbers in the parentheses for your C's. But when you're doing function values and finding zeros, it always stays the same. All right, so we're looking for our remainder. So once again, the first number, you bring straight down. Any number that's down here multiplies to get the next column. So 1 times negative 5 is a negative 5. Add the column up. So if I was going to write notes on this, and I'd say bring the 1 down, multiply 1 times negative 5, and put under the negative 13. Next, I'm going to add the column negative 13 plus the negative 5, and that's going to give me a negative 18. So that negative 18 will come down. And then once again, repeat everything. Negative 18 times negative 5 is a positive 90. You would then add the 52 and the 90. That would give me 142. So calculator's going to help me on this one. 142 times negative 5. Ooh, that's a negative 710. And then finally add that negative 710 to a negative 60. And you're going to end up with a negative 770. So f of negative 5 is going to equal a negative 770. Which is cool because this is a new way you can find function values instead of going in there and plugging that negative 5 in for all the x's, okay? All right, so my second answer was negative 70, and then I got to find, what was it, f of 6. So here was my f of negative 5. I didn't write that. Now f of 6, I'm going to write the same numbers out. 1, negative 13, 52, and negative 60. And I'm going to draw my box. And then my C was the positive 6. All right, so when I'm done, I will have a value here that will be what f of 6 equals on this one, okay? So once again, bring the first number down. Multiply 1 times 6 and put that under the negative 13. Add the negative 13 and 6, we get a negative 7. Multiply the negative 7 times 6 and put that under the 52. So that'd be what, a negative 42. 52 minus 42 gives me a 10. And then I repeat the process one last time. 10 times 6 is 60. And then negative 60 plus 60 gives me a 0. So that means f of 6 equals 0. So y'all, it's not too bad. You just get used to the little pattern on it, okay? And watch for missing terms on those. All right, so let me turn. All righty, so given f of x equals x to the fourth minus x to the third minus 6x squared plus 32x minus 33, they want me to find f of a negative 5. All right, so let's see, I got my x4 term, x3 term, x squared term, x term, and my number. So nothing's missing in that order. So I'm going to write out all my coefficients. So the x4 would be a 1, negative x3 would be a negative 1, negative 6x squared would be a negative 6, 32x, I write my 32, and then I bring down my negative 33. Draw our little box. And once again, I'm looking for that remainder. My C will be negative 5. All right, y'all, so here we go. First number comes straight down. And then I'm going to start multiplying. 1 times negative 5 is negative 5. I'm going to add the column. Negative 1 plus negative 5 is a negative 6. All right, negative 6 multiplies by negative 5, making a positive 30. Negative 6 plus 30 is going to give me what? A 24. All right, 24 times negative 5, that's what? Negative 120. All right, so I got a negative 120. I'm going to add to a positive 32. That's going to give us a negative 88. All right, so that negative 88 times that negative 5 is going to give me a positive 440. So add that 440 to that negative 33. That gives me a final answer of a 407. So y'all, synthetic division gets these function values pretty quick. It's quicker than coming in here and putting all these negative 5s in. So I'm going to do this one by hand by putting a negative 5 in just to show you that this answer will be the same as that one. So I got negative 5 to the fourth power minus negative 5 to the third power minus 6 times negative 5 squared plus 32 times negative 5, and then minus my 33. When I hit enter, hopefully I get 407. So a lot of times that's what I'll do on function values. If I don't want to mess with big exponents, I'll just do synthetic division, and that knocks them out pretty quick. Alrighty, so using synthetic division, determine if the number is a 0. So here's a little rule on this. If a number is a 0, then the remainder of synthetic division is 0. So if I get a 0 remainder when I use synthetic division on these numbers, then yes, they are a 0. If I get any other number for my remainder, then you got to put no on that, okay? So is -5 and 3 zeros of f of x equals 2x to the third plus a 7x squared minus 11x plus 20. Now we'll say this, you got to work this twice and put your answers in the order that they're giving you the numbers. So since -5's first, you want to run that 0 first and then do the 3. So I'm going to work -5 first. So remember, I got to write my numbers. So I got my x3 term, x squared term, x term, and my number. So nothing's missing. So I got to write my 2, 7, -11, and my 20. And then draw my little box. So to put yes, I need a 0. Any other number, I put no on this, okay? All right, so first step, bring down that 2. Now, then you want to multiply 2 times -5, and that's going to give you a -10. -10 plus a +7 is going to give us a -3. -3 times -5 is a +15. -11 added to a +15 gives me a +4. And then here we go. 4 times -5 is a -20. And y'all look at that. 20 and -20 give me a 0. So since my remainder is 0, -5 is definitely one of my solutions. So then you come right by it, and you got to run to 3 to see if it's a 0 or not. So you're going to have the same numbers, 2, 7, -11, and a 20. All right, so we got to run to 3 this time. So the first step again is to bring down that 2. Then you're going to do 2 times 3 is 6. Add 7 plus 6, so what's that, 13? Multiply the 13 times the 3, which is 39. 39 plus a -11 is a +28. Right, here we go. 28 times 3. Oh, what's that, 84, I think? Yeah. And then finally add 84 plus 20, which is going to give me, what, 104. But really, once I knew that wasn't going to be 0, all I had to do was come and put no. Okay, so to find if they're zeros or not, you got to get a 0 remainder. Up here, we were finding function values, and function values were equal to those remainders. which means on this problem I just did, if I wanted to find f of -5, f of -5 would have equaled 0. F of 3 would have equaled 104. But we didn't have to find function values. They just wanted to know, was it a 0 or not, okay? All right, y'all, so the next one's going to be doing the same thing. Is -2 and 1 a 0 of, all right, this one has h of x equals x to the 4th. I know I moved it down while going. I didn't put it back up. All right, so is -2 and 1 a 0 of h of x equals x to the 4th plus 3x to the 3rd plus 2x squared minus 7x plus 1. And y'all notice we make these polynomials long as we want, right? All right, so I'm going to try the -2 first. Let's see, I got an x4 term, x3 term, x squared term, my x term, and my number. So nothing's missing, so let me write out these numbers. I got a 1 for the x4, 3 for the x3, 2 for the x squared, -7 for the x, and then my 1. Alrighty, so I'm looking for a 0 remainder to be yes. Anything else is a no. All right, so first, I'll bring down my 1. All right, 1 times -2 is a -2. All right, then I add 3 and -2 gives me 1. 1 times -2 is a -2. So let's see here. 2 and -2 add to get a 0. 0 times -2 is 0. -7 plus 0 is -7. And y'all look at that. -7 times -2 is a positive 14. 1 plus 14 is 15. So since that's not a 0, this is definitely not a 0 of that function. I'll show y'all another trick. But in order for these numbers to be zeros, they got to be factors of these numbers, the first one and the last one. And we'll learn about that probably Monday. All right, so let me write my coefficients. 1, 3, 2, -7, and a 1. All right, so this time I'm taking a positive 1, which 1 is a factor of 1, so it's probably more possible for this one to be a 0 than it was for the -2, because -2 is not a factor of 1, okay? All right, so here we go. Bring that 1 straight down. 1 times 1 is 1. Add that 3 plus 1, that's going to give me, what, a 4. 4 times 1 is 4, so bring that to the next column. 2 plus 4 gives me a 6. All right, so let's see what's happening. 6 times 1 is 6. Add that -7 and 6, you get a -1. And look here, -1 times 1 is a -1. And when you add 1 and -1, you get a remainder of 0, which means 1 is a 0 of that polynomial. All right, so y'all getting used to this synthetic division?
A little bit.
I was wondering what to think on that now. Well, you know, we got y'all's favorite numbers coming up. So we're going to determine if a negative 3/2 is a 0 of f of x equals x to the third plus 5/2 x squared plus a 9/2 x, and at the end is a positive 9/2. So, you know, once y'all get good at something, we always like to break out the fractions. So let's see, RC will be the negative 3/2. Let's see, I got my x3 term, x squared term, x term, and my number. So the x3 has a 1 in front of it. Then I got a 5/2, a 9/2, and then another 9/2. So all I'm looking for is a 0 remainder to be yes. Anything else will be a no. So y'all, this looks pretty intimidating, but watch what happens. Bring that 1 straight down. And then multiply 1 times a negative 3/2 is going to be a negative 3/2. Now, if you don't like adding those by hand, come on, calculator. 5 divided by 2 plus negative 3 divided by 2 is going to give me 1. So remember, all they did, 5/2 minus 3/2. The bottom will stay halves, and then everything gets done on top. 5 minus 3 is 2. But then they said, hey, we got 2 over 2, which is a 1. All right, 1 times negative 3/2 is a negative 3/2. So let's see what that is. 9/2 minus 3/2. So the bottom's going to stay at 2 at this point. 9 minus 3 is 6. And y'all look at that. 6 divided by 2 will make that a 3. So they were nice and made everything have a common denominator so that we wouldn't have ugly fractions down here. Now, 3 times a negative 3/2. So let me show you how I'd multiply that. I would treat the 3 like it had a 1 on the bottom and multiply straight across. So negative 3 times 3 is negative 9. 2 times 1 is 2. So 3 times a negative 3/2 is a negative 9/2. And y'all look at that. 9/2, negative 9/2 gives me a remainder of 0, which means yes, negative 3/2 is a 0 of that polynomial. Hey, so they're not bad. You just got to get used to the writing out your numbers. Bring your little C over, which is the number you're checking. And then it's always bring the first one down, multiply to get the next column, add. Take that answer, multiply, get the next column, add. Take that answer, multiply, get the next column, add, and be done. So that was 8.3, and it was just get you knowing what to do with synthetic division, okay? I'm sending out a support video that'll show you what to do to find quotients and remainders. Alrighty, so we start 8.4 next. And 8.4 is really what we would call theorems about zeros. So things we're looking at in here, the first thing we're going to do is I'm going to find a polynomial of degree 3 with real coefficients that has zeros of -1, 2, and -5. So the first thing, they want me to find a polynomial when I'm done, and they're telling me that the highest exponent it can have is a 3. That's what they mean by degree 3. If you end up with an x4, it's going to be wrong. If you end up with an x squared as your highest exponent, it's going to be wrong. The highest exponent has to be a 3. Now they're telling me it has zeros of -1, 2, and -5. So remember, zeros are the solutions, okay? So that means you got an x that equals a -1. You got an x that equals a +2. And then you're going to have one x that equals a -5. So here's what's going to happen. To find the polynomial, I've got to take these answers and work in reverse to get to my polynomial. It's going to be reverse of the stuff where y'all was factoring. When we gave y'all polynomials and said find the solutions, you went through, factored it, set each equal to 0, and then you got your answers like this. So we're going the other way. So to go the other way, the first thing you want, you must have zeros on the right side. Of the equations. So to get a 0 on the right side of all these, I'm going to do the opposite. So the first one, you would add 1 to both sides, and you get x plus 1 equals 0. Second one is positive, so you would subtract 2 from both sides and get x minus 2 equals 0. And then the third one was negative, so you would add 5 to both sides, and that would give me x plus 5 equals 0. So you got 3 factors equal to 0. So would I not be able to add all, not add them, but multiply all 3 of these factors? And if I multiply all 3 of these factors, they should still equal 0. So y'all see what's happening? We're going totally in reverse of what y'all were taught up to this point, okay? Now, you got 3 things being multiplied. So what I'm going to do first is FOIL the first 2. So this x plus 1 would technically come down. And then we're going to FOIL this part. So x times x would be an x squared. X times 5 would be a 5x. -2 times x is a -2x. And then -2 times 5 is a -10. All this is still equal to 0. And y'all, if you notice one more thing, before I multiply again, I can add like terms in this. So I'm going to bring down that x plus 1. Let's add like terms. So I bring my x squared down. 5x's and a -2x's is going to make that a 3x. Bring down to -10. All this equal to 0. Now you could have took this and did side work, figured out what that equaled, and then put it back in, okay? All right, now I'm going to do a FOIL again, but it's really a FOIL on steroids because you got 2 things times 3 on this, okay? So I multiply everything by the x, and then I multiply everything by the 1. So here we go. X times x squared is an x to the third. X times 3x is a 3x squared. So all you're doing when you multiply by x is adding an x to everybody. X times negative 10 is a negative 10x. So I went from 2x's to 3, 1 to 2, none to 1. Now, multiply everybody by the 1. 1 times x squared is x squared. 1 times 3x is a 3x. 1 times negative 10 is a negative 10. And all this is still equal to 0. Alrighty, so it looks like you got a few like terms down here, so I'm going to bring down the x to the third. Let's see, the x squareds will add together. So 3x squareds plus 1x squareds will give me 4x squared. The x's will add, so negative 10 plus 3 would give me a negative 7x. And then at the end is your minus 10, all equal to 0. What MATLAB wants is this polynomial right here. And guess what? They wanted a degree 3. My highest exponent is a 3. So when you're done with these, if they tell you what degree it's got to be, you got to match up with that exactly, okay? Which means the first part of 8.4 is nothing but FOILing. All right, y'all, so next problem. So this one just says, find a polynomial with zeros of 2, 7i, and a negative 7i. So y'all, we're going to do this with imaginary numbers. So we'll bring back memories on y'all's imaginary numbers, I guess, on multiplying. Now I'm picky on this one. I'm going to have my x equals 2, my x equals 7i, and then x equals a negative 7i. Okay. Now, you can either put these first or keep them in the order I got it. But the thing is, when you FOIL these, you want to FOIL the imaginary stuff together first, and then take that answer times the real number. So let's get everything on one side equal to 0, and I'll show you. So since that's a positive 2, we're going to minus 2 from both sides. And I get x minus 2 is 0. That's a positive 7i, so I would subtract it from both sides. So I get x minus 7i equals 0. And then that's a negative 7i, so I would add 7i to both sides. And I get x plus 7i equals 0. Okay, so I'm going to bring up a piece of paper so I don't mess up this problem. And I'm going to recall y'all. Whoops, recall. So x plus, what did I have? 7i. And x minus 7i. I just want to recall y'all on FOILing one of these real quick. Now, here's the thing about imaginary numbers. If you ever get an I squared on here, well, let's ask the calculator. There's a little I by the decimal down here. So if you hit second and then the decimal to bring up the I, and then I'm just going to square that. I squared always equals -1. So when you're multiplying, if you get an I squared in your answer, you got to replace it with a -1. You cannot leave I squareds in your final answers, okay? Now, these are conjugate pairs, x plus 7i, x minus 7i. Conjugate pairs are the same except for their signs. What's nice about foiling conjugate pairs of imaginary numbers is after I foil this, there will be no more imaginary numbers. They cancel out. So y'all watch the process. X times x is the x squared. X times -7i is a -7ix. Then you start on the inside. Positive 7i times x is a positive 7ix. And then 7i times a -7i is a -49i squared. So I said if you ended up with an I squared, you're going to replace that with a -1. So watch what happens here. This x squared will come down. Here, -7x and a positive 7ix, they cancel. Conjugate pairs always, 100% of the time, cancel the middle two terms. Now, this was a -49i squared, but if I change the I squared to a -1, I now have a -49 times a -1, which will give me a positive 49. So by foiling these imaginary numbers, I ended up with a real number. Imaginary numbers cancel out. Okay? Now, anytime you foil conjugate pairs of imaginary numbers, it'll always end up as an x squared plus whatever that number is, okay? So now, that brought back memories on that, right? So I can set all three of these in parentheses. All equal to 0. And I started out with my imaginary stuff foiling it. Right? So I know I bring down my x minus 2. When I foiled this just now, we got what? X squared plus 49. And all that's still equal to 0. Now, I will tell y'all a trick. Since I got 3 zeros here, 2, 7i, -7i, the highest exponent I should end up with is a 3. Okay, so the number of zeros tells you what that degree should be. All right, so now the x minus 2 and the x squared plus 49, I'm going to foil again. So here we go. X times x squared is an x to the third. X times 49 is a 49x. -2 times x squared is a -2x squared. And then -2 times 49 is a -98, all equal to 0. So the only thing I would do to that is just maybe rearrange it so that I got all my exponents in order, so that I got my x to the third minus my 2x squared plus my 49x minus my 98, all equal to 0. So that our final answer is that polynomial right there. All right, so that brought back memories on imaginaries. My next problem, I'm going to bring back memories of your radicals, but that's going to be after break. So let me let y'all catch that up. I'm going to stop that sharing and take us to the break. And then back on our screen. All right, so the next one I'm going to foil is going to have radicals in it. So find a polynomial of lowest degree. That has zeros. So it has zeros of square root of 5, negative square root of 5, and, oh, what was my other one? And a 2. So basically the same thing. I'm going to put my x equals, now I'm going to put my 2 first, and then I'm going to put my x equals square root of 5, and then x equals a negative square root of 5. All right, I want everything on one side, so I'm going to subtract and add to get zeros on that right side. So since that's a positive 2, we subtract 2, and I get x minus 2 is 0. That's positive square root of 5, so I subtract a square root of 5 from both sides, and I get x minus square root of 5 equals 0. This is the negative square root of 5, so I'm going to add a positive square root of 5 to each side, and I get x plus square root of 5 equals 0. All right, then I'm going to put everybody in parentheses equal to 0. So once again, I'm going to play with this part right here, the x minus square root of 5 times the x plus square root of 5. So let me FOIL that out, and then we'll put that answer over there. So remember, these are conjugate pairs also. And anytime you FOIL conjugate pairs of radicals, the radicals will all disappear on this, okay? So watch this. X times x gives me x squared. X times square root of 5 is a square root of 5 times x. Now notice, I didn't put the x under the radical. When you multiply stuff in radicals, what's inside a radical can only multiply by other things inside radicals, okay? All right, negative square root of 5 times x is a negative square root of 5 times x. And then watch this. Negative square root of 5 times a positive square root of 5 is a negative square root of 25. So since these 5s are both under the radical, you multiply to get that to be a 25. So what's happening here, you bring the x squared down. These middle terms are going to cancel. And y'all remember, like I said, 100% of the time on conjugate pairs, those middle two terms are going to cancel every time. And then it's minus. Well, I know what the square root of 25 is going to give me. Square root of 25 is going to give me a 5. So check this out. When you FOIL conjugate pairs of radicals, you get an x squared minus some number. When I FOILed conjugate pairs of the imaginary numbers a while ago, it ended up as a x squared plus that number, okay? So this is going to be x squared minus 5. So I'm going to put that right here where I FOILed this. So I'm going to bring the x minus 2 down. This gave me what? An x squared minus 5. All right, so I FOILed those, got this answer. Now I'm going to FOIL this. Now remember, since I had 3 zeros they gave me, When I'm done, my highest exponent has to be a 3, okay? All right, so here we go. X times the x squared gives you an x to the third. X times -5 gives you a -5x. All right, next is the -2 times x squared is a -2x squared. And then at the end, -2 times -5 gives me a +10, all equal to 0. So y'all, the only thing I would do to that would be putting in descending order. So I'm going to put my x to the third minus my 2x squared minus my 5x plus my 10, all equal to 0. So let's see, that there would be my final answer. So these aren't real bad. You just got to keep up with that foiling and make sure you're simplifying those terms as you go through there, okay? Alrighty, so here's some little rules about zeros. Rules about zeros. So the first rule is that radical zeros always come in conjugate pairs. And y'all been seeing that, the -5s, the negative square root of 5 and a positive square root of 5. And then a while ago I had, I think, a 3i and a -3i. So what this means is if 2i is a 0, then -2i is a 0. Whoops, hold on, my bad. Erase that. If square root of 2 is a 0, then a negative square root of 2 is also a 0. I forgot I'm on the radicals. So if a square root of 2 is a 0, then a negative square root of 2 automatically has to be a 0. If 3 minus the square root of 2 is a 0, then 3 plus square root of 2 is a 0. Notice, the 3 didn't change signs, only the radical stuff changes the signs, okay? So if 3 minus square root of 2 is a 0, 3 plus square root of 2 will be a 0. That's sort of like that quadratic formula stuff y'all were doing. The plus and minus, that's how they're getting those two numbers, okay? All right, so that was radical zeros. Now we're going to look at imaginary zeros. And guess what? Imaginary zeros always come in conjugate pairs. So always come in conjugate pairs. Okay, so now I can say this. If 2i is a 0, then -2i is a 0 also. And I can make them look like complex numbers. How about if 5 plus 3i is a 0, then 5 minus 3i is a 0 also. Once again, the 5 don't change signs. It's the imaginary part that changes the signs, okay? So, radicals always come in conjugate pairs. Imaginary numbers always come in conjugate pairs. Okay, so I'll let y'all write that, and then I'll hit y'all with the next examples. Alrighty, so in these examples, suppose a polynomial of degree 4 has the zeros of -4, let's see, square root of 2, and 13/4. Find the other zero. So they gave me 3 of the 4 zeros. I got to find what's the 4th zero. And it goes off of what I just wrote down a while ago. Notice, I don't know nothing about that -4, but I do know if a square root of 2 is a 0, then the other zero has to be a negative square root of 2. And then we didn't have no rules about the fractions. So the only one we can guarantee has a conjugate is the square root of 0, okay? And we're going to put negative square root of 2 since radicals come in conjugates. Okay? So since radicals come in conjugates, we automatically knew to change the sign of that one, and we're done. So once again, suppose a degree 4 polynomial So a polynomial of degree 4 has the zeros of I and 5 minus a square root of 11. Find the other zeros. So I got a degree 4, which means I end up with 4 zeros. Now they're only giving me 2 of the zeros this time, but I do know that the i's come in conjugate pair. So if I is a 0, its conjugate would be a negative I. I also know that these radicals come in conjugates, and if 5 minus square root of 11 is a 0, the other 0 would be 5 plus square root of 11. And that would be because imaginaries come in conjugates, radicals come in conjugates. All right, then the last one, suppose a polynomial of degree 4 has the zeros of, how about a 3 plus 2i and 3 plus square root of 2. Find the other zeros. So I do know that both of these always come in conjugate pairs. So if 3 plus 2i is a 0, I need 3 minus 2i. And then if 3 plus the square root of 2 is a 0, I need 3 minus square root of 2. So once again, notice The real numbers do not change, only the signs of the imaginary and the radical parts, okay? Alrighty, y'all, so the next problem is going to be a little deeper. So we got two where we got to find zeros, it looks like. So the polynomial has the given zero. They want me to find the other zeros. All right, so my polynomial is f of x equals x to the third plus 3x squared minus 2x minus 6. The number I'm checking is a -3. So what you want to do to this, since -3 is a zero, we're going to use synthetic division. So here we go. Since -3 is a zero, we use synthetic division to divide out that zero's factor. Then now this one's an x3, so on this one, I'm going to factor out that zero. Then we use quadratic formula to find the last two zeros. And to find them, I'm going to use the quotient of my synthetic division. So when it starts with an x3, you got to get the quotient down to an x2 and then use the quadratic formula. The one after this example has an x4, so you do synthetic division twice, then you can use the quad to get the last two zeros. So we can always use the quad for the last two zeros. It's just getting to that point, okay? So since we're going to use synthetic division first, we're going to write out our coefficients. So I got my x3 term, x squared term, x term, and number. Nothing's missing. So I got a 1, a 3, a -2, and a -6. That zero they gave me was a -3. Now, since -3 is a zero of this problem, after synthetic division, we better have a zero here, okay? So what we'll do, since there will be three numbers under the box here, those three numbers I'm going to use as my ABC for my quad. So if you don't get a zero here, you've done something wrong here, so you better start over, because since -3 is a zero, I got to get a zero here, okay? So the first number, 1, comes straight down. 1 times -3 is a -3. That goes in the next column. Then you add 3 and -3, you get a 0. Then you multiply 0 times -3 is 0. That goes in the next column. Then I'm going to add that column. -2 plus 0 is -2. All right, then I take that -2 times that -3 is a +6. And y'all look at that. -6, +6 gives me a remainder of 0. These three numbers are the quotient. So what really happens, since this is the quotient, you start out 1 degree less than your original polynomial. So since the original polynomial was the x to the third, this quotient starts as 1x squared. That becomes a 0x minus 2. You would set all that equal to 0. So now I could use the quad. So that's why we gave you the quad program. Because at this point, you could use the quad program. So you would go to program, go down to quad, hit enter, and then you just put in the 1 for the A, a 0 for the B, a -2 for your C, hit enter. Now remember, I don't want decimals, so I hit enter one more time, and I get 0 plus square root of 2, 0 minus square root of 2, which means I get a square root of 2 and a negative square root of 2. So what the answer is wanting would be these two zeros that you get from quadratic formula. Now, anybody doing the quad by hand? I'll knock that out real quick if you need.
I am. Winnie is.
Say again?
Winnie is. I do it by hand. I don't
Okay,
do it on
so
the calculator.
so I had my 3 numbers. So watch this. We had A is 1, B is 0, and then C was a -2. So here we go. X equals -b plus or minus square root of b squared minus 4 times a times c all over 2 times a. But what's nice is b is 0, so that's 0 in them 2 spots. A was 1, so that'll go here and here. And then C was a -2. That's going to go right there. So I love this one because negative times 0 is still a 0, plus or minus. 0 squared is 0. Now watch for this end. You got a -4 times a -2. That's going to make that a +8 all over 2. So it looks like, wow, how are they going to get to that answer, right? Well, 0 plus 8 gives me an 8. All that's over 2. So y'all, the trick now is to simplify that square root of 8. So remember, to simplify a radical, you got to pull out any factors that are perfect squares. So the perfect square factor of 8 would be a 4. So that this becomes a 4 times a 2. But y'all, the square root of 4 is 2. So that gives you a 2 square root of 2. So I'm going to replace the square root of 8 with a 2 square root of 2. So I get 0 plus or minus 2 square root of 2 all over 2. And then when Sheldon, remember the last step on that is all 3 of these outside numbers will divide by 2. So I got to divide everybody by that 2. So that basically 0 divided by 2 is still a 0. Plus or minus 2 divided by 2 gives me 1 square root of 2. And just remember, in MATLAB, you don't want to put the zeros. So you'll just put the square root of 2 and then your negative square root of 2, okay? So the trick is really being able to simplify them radicals. Say again?
Right. I got it. Yes, sir.
Okay. So that's the trick on those, is just being able to really simplify them radicals, okay? Well, that one had 3 zeros. The next one's going to have 4 zeros. So, they're giving us f of x equals x to the 4th plus 7x squared minus 144. They're telling me 4i is a 0. Find the other zeros. So let me tell you what. Since I got an x4 and I can't use the quad till I get it to an x squared, we have to do synthetic division twice before we can do the quad. For the last two. So quad always finds the last two. You just got to get the first two on this. So, oh, y'all look at here. I got an x4. There's not an x3 term, so I will use a 0 for it. I got the x squared term. I don't have an x term, so I'm going to use a 0 for it. And then I got my number. So any missing exponents have to have zeros. So that this would be a 1 for the x4, 0 for the x3, 7 for the x2, 0 for the x term, and at the end is a negative 144. So we're going to draw our box. The first number they told me to check was a 4i. Now notice, you had 5 numbers here, so this is going to be the remainder. We're going to still have 4 numbers when we do the quotient. That's why we're not able to use the quad. We got to get that down to 3 numbers before we can use the quad. So let's see how y'all are with imaginary numbers. So the first one is coming straight down. Also, let's see, 1 times 4i is 4i. 0 plus 4i is 4i. So I'm wondering what's going to happen. Y'all got these calculators. When you multiply 4i times a 4i. So 4 second decimal brings the i's up times 4 second decimal. So I now have a 4i times a 4i, which will give me a 16i squared. But remember, what did we say I squared equaled? -1. So that's going to be 16 times -1, which better give me a -16. All right, now 7 and -16 give me a -9. Now remember, if we're doing this right, when we're done, we better get a 0 remainder, okay? All right, y'all, -9 times 4i is a -36i. 0 and a -36i is a -36i. So now watch this. I'm going to multiply 4 second decimal to get the I times a -36 second decimal to get the I. That's going to give me a positive 144. And look at that. -144 plus 144 gives me a 0 remainder. So now what you would use, these 4 numbers, you bring them down. 1, 4i, -9, and -36i. And you're about to use synthetic division again. So, oh wow, I need to find a number that I can try next, right? So I know I can't use quad till I get it down to 3 numbers. So y'all, what number would I try next? So think about this. Those examples I did before this section.
The 7.
Well,
Is it going to be 2
oh, I'm going to get y'all. Remember,
or 3?
check this out. If 4i is a 0, then who else should be a 0?
The negative 4i.
Bam, so I'm going to use negative 4i next.
Oh my.
So remember, if I give you an imaginary zero, the next zero has to be its conjugate. Okay? So guess what? We bring the 1 straight down. But watch this. This imaginary stuff's about to disappear. 1 times negative 4i is a negative 4i. Well, look at that. 4i and negative 4i add to give you a 0. 0 times negative 4i is 0. Negative 9 plus 0 is negative 9. Oh, and y'all look at this. A negative times a negative makes that a positive 36i. And guess what? Negative 36i plus a positive 36i gives you a 0. Now, I'll tell y'all a little trick. Since that last number was a negative 36i that they had brought down, you had to multiply by some kind of I to get rid of that, okay? So now, you got 3 numbers left. Since I got 3 numbers left, I can now use the quad formula. So what I have, 1, 0, and negative 9. So that'll be my A, B, and C. So we got x equals negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. But you'll notice a lot of times in this, those b's are going to be zeros. What was my a? A 1 here and here. And then c was a negative 9. So that's going to give me 0 plus or minus square root of 0. Let's see, this side has 2 negatives, so that's going to be a positive. Let's see, 4 times 9 is what, 36? All over 2. All right, so add the radical so that you get 0 plus or minus square root of 36 over 2. Now, here's the thing that gets a lot of people. Some of my people try to divide that 36 by that 2, but y'all, numbers inside a radical cannot divide by numbers outside a radical. So that means you got to take the square root of that 36 first. And the square root of 36 is 6 all over 2. So here we go. To get my 2 answers, you would do 6 divided by 2 positive, and then 6 divided by 2 negative, so that you get a positive or negative 3 on that one. So my other 3 zeros were, what I get, a negative 4i, a 3, and a negative 3. So y'all, on this one, if you got 4 zeros and they give you an imaginary 0 or a radical 0, you want to use its opposite before you get it down to the quad part, okay? That's probably the trickiest one I'm going to hit you with. All righty, so the last topic on this section. And so the stuff I'm about to do, say I gave you a problem, but I didn't give you no zeros. This shows you how to find numbers that you would check to be possible zeros so that you're not wasting all your time, okay? So this is how to finding all possible zeros of a polynomial. So here's the trick. We find what we call P over Q, plus or minus P over Q, where P is all factors of the last number, Q is all factors of the first number. So this is what I was talking about earlier when I was doing the zeros on the very first few problems, and I said, well, 7 wasn't a factor of that last number, so it wouldn't be a zero. This is what that's going to. So basically, we're going to take all factors of the last numbers and divide each of those factors by all factors of the first number. So I'll figure out my P's and my Q's, and then I start taking every P and divide by all the Q's. So you might have a lot of combinations, but it's better than checking every single number for possible zeros, okay? So we're going to be given P of X equals, what is that, 22x to the third minus 36x squared plus 48x minus 21. So P is the last factor. Q will be all the factors of the first number. So the last number was what? 21. So factors of 21 are 1, 3, what's left? 7 and 21. So those are the only factors that multiply to get me a 21. The first number was 22. And all the factors of 22 would be what? A 1, a 2, 11, and 22. All right, so now we got to find the plus or minus P over Q's for all of this. So I'm going to start with the 1 up here. So I got a plus or minus 1. And I'm just going to divide that 1 by all 4 of these numbers. All right, so I took my 1 divided by 1, took my 1 divided by 2, took my 1 divided by 11, took my 1 divided by 22. Now, one of these will simplify. That 1 over 1 will turn into a plus or minus 1 only, okay? So the first 4 possible zeros are plus or minus 1, plus or minus 1/2, plus or minus 1 over 11, plus or minus 1 over 22. Then I would take the second P, which is 3, and divide by all 4 of these numbers. So 3 divided by 1, 3 divided by the 2, 3 divided by the 11, and then 3 divided by 22. And once again, you can simplify the plus or minus 3 over 1 to just a plus or minus 3. So notice I've done the 1, I've done the 3. Next I'm going to do the 7. I'll divide 7 by 1. I'll divide the 7 by the 2. I'll divide the 7 by the 11. And then I'll divide that 7 by 22. And once again, 7 over 1 will just turn into a 7. All right, so that takes care of my 7. And finally, I got to do my 21. So I divide 21 by 1, 21 by the 2, 21 by the 11, and then finally, 21 divides by 22. And y'all, the only one I can simplify is 21 over 1 will turn into a plus or minus 21. So your answer would have every single one of these listed. So let me show you how they put them. There you go. So you got to find the one that's got all your fractions in it, okay? And then remember, you got to use the plus or minus because those could be plus ones or negative ones. So when you come to one of these that don't have no signs in front of it, you might as well just throw it out, okay? All right, so all these were my possible answers on that one. So let me hit y'all with my last question. Let me let y'all catch them up. And just remember, those ain't all the zeros, they're what we call possible zeros, which means that some of them numbers would have been zeros, okay? So this one has f of x equals 13x to the 6 plus 7x to the 3rd plus 16x squared.
Mr. Eugene, can you move it down?
I do that every time.
Thank you.
18x, and at the end is a negative 21. So once again, they want to find all possible zeros. All right, so we're going to look for our P and my Q. P is the last number, so that's 21. So I'm going to write its factors, and then my first number is a 13. I'll write its factors. So the factors of 21 are 1, 3, 7, and 21. Factors of 13, so that's a prime number, so it's just going to be 1 and 13. So once again, I'm looking for all my plus or minus P over Q's. So I'll take all these P's and divide everybody by these two numbers. So I got plus or minus 1 divided by 1, plus or minus 1 divided by 13. So the 1 over 1 can be simplified to a 1. So that takes care of the 1 being divided twice. Then I'm going to do this 3. So 3 divided by 1, 3 divided by 13. I can simplify the 3 over 1 into a 3. So far I got a plus or minus 1, plus or minus 1/13, plus or minus 3, plus or minus 3/13. Then I do the 7. So plus or minus 7 divided by 1, plus or minus 7 divided by the 13. 7 over 1 can be simplified to a 7. So I've done 3 numbers. I'm left with my last number, which is the 21. Divide it by the 1, and then divide 21 by the 13. Once again, 21 over 1 reduces to a 21. So I've taken all 4 of these factors from the last number and divided every single one of them by the 2 factors of the first number. So y'all, let me show you what, we don't have no problems doing this, but I'm going to show you why they have you do that. So this is just my last example showing you that. So I'm given f of x equals 2x to the third plus 7x squared plus 98x plus 343. I'm going to find the zeros. But this time they didn't really give me no zeros to start with. So I do know my zeros will be any numbers that are factors of the last number divided by factors of the first number. So factors of 343, that's a bunch of 7s. So factors of 343 would be 1, 7, 49, and 343. So factors of the first number would be 1 and 2. So what I would do first is take all the factors and divide by 1, because those are whole numbers. Then I would start messing with the numbers all divided by 2. So the numbers I'll check first is 1, -1. Then I'm going to start with 7, -7. Then I'll do 49, -49, 343, -343. If those don't work, then I'll start doing the fractions by dividing by 2. But y'all, I got a calculator here. So watch this. I'm going to put this polynomial in there. 2x exponent 3 plus 7x squared plus 98x plus 343. I'm going to graph it, and the calculator is going to tell me where to start. Because if you see this number right here, it looks like a fraction, don't it? It don't look like it's going straight through that line, does it? So let me zoom in just a second, see if I can zoom that in. Too close. Let me go left. Well, hell, zoom it back. Let's see, that looks like a 1, 2, 3. That looks like about 3.5. So that means one of these numbers equals around 3.5 on the negative side. So 1 divided by 2 gives you a 0.5. What about 7 divided by 2? Oh, 7 divided by 2 is a 3.5. And my graph was on the left side. So my first zero I'm going to try is going to be that -7/2. Now my numbers will be 2, 7, 98, and 343. But y'all notice what happened. I used the calculator to help me, but I would have went through 1, 2, 3, 4, 5, 6, 7. I would have went through 8 numbers first, and none of them would have been a zero. I'd have been doing a whole lot of synthetic division, trying to get a zero remainder, and none of those numbers would have worked. It had to be one of these fractions. All right, here we go. The 2, bring it straight down. 2 times a -7/2 is going to be a -7 because them 2's cancel. 7 and -7 are 0. Now, y'all remember, I'm not giving y'all no homework over this. I'm just showing you why you had to learn all that possible rational zeros, okay? All right, 0 times -7 halves is 0. 98 plus 0 is 98. So let's see, what is 98 times a -7 halves? Hopefully it's a -343, which I needed. And that gives me a remainder of 0. So now that I know -7 halves is my first 0, I can use this with the quad to get my last two zeros. So I would come in -b plus or minus square root b squared minus 4ac all over 2 times my a. And notice, once again, I got zeros on this for the b. A was a 2 this time. C was a 98. All right, y'all, this side is 1 negative. So 4 times 2 is 8. 8 times 98. Whoo, that's a negative 784. All that over. 2 times 2 is 4. All right, so let's bring this down. That's going to give you 0 plus or minus is negative 784 under my radical, all divided by 4. So let's see if the 784 is a perfect square or not. So I'm going to just try to take the square root of that. Second, x squared from my radical. I ain't worried about the negative at the moment. I just want to see if 784 is a perfect square root or not. When I hit enter, oh, it is. Look at that. So you now have 0 plus or minus 28 all over 4. And remember, there is a I behind that 28, right? Because that was negative under that radical. So you get 0 plus or minus 28 over 4, which divides and gives you a plus or minus 7i. That's why on the graph, we didn't see no more crossing, because the last two zeros are imaginary. Okay? So my 3 zeros would have been -7 halves, 7i, and a -7i. But y'all, you don't have to do this problem on homework. I just wanted to show you what you needed to learn, that possible zeros. So notice, I would have never done synthetic division on numbers like 2, 3, 4, because they weren't factors of that last number. So I'm sending out a video also to help on the support, because the support does synthetic division, but they just say find the quotient and remainders. Okay. Ooh, that took us all the way through. So let's stop that. And then I will stop this video.